Good morning, chemistry students. Here we go with today's lesson. So today, we're going to still kind of put things together, and we're going to do something called skeleton equations. All right, skeleton equations. Today is the 20th. Okay, so when you think of a skeleton, it's something that just has bare bones. There's no muscles, no tendons, no ligaments, no skin, no veins, capillaries, arteries, nothing. Um, and so a skeleton equation is something that is uh, just the symbols. It's not going to be balanced, and it's not going to have any coefficients in it. So before we go and learn how to do skeleton equations, there are just a couple of things that we need to talk about. One is states of matter. Um, you might hear in a chemical formula something described as like a gaseous form of blah, blah, blah. A gaseous form of oxygen combines with aqueous nitrate. All they're simply doing is they're telling you what the state of matter is. So here are the symbols that go along with it. We have G for gas, S for solid, L is liquid, and then the one that is aqueous. Aqueous just means that it's in water, it's in liquid, or it's mixed with water. So what this might look like is you might see a formula like Mg plus H2O yields Mg parentheses OH2. And maybe when you're looking at it, maybe there is a little S here, maybe there's an L here, and there's an AQ at the end. So all they're doing is the person who's writing this equation is letting you know what state of matter they're working with. So magnesium is going to be a solid. Water is a liquid. Magnesium hydroxide is in water. It's a aqueous solution. So those little symbols don't really affect the formula that you're writing. It's just telling the person who's reading or analyzing the chemical equation what state of matter the original person was working with. So if you see these, I don't want you to be surprised. You're like, what is that? Where did it come from? All right. The next one that we have to talk about are diatomic elements. All right. Diatomic elements. So if something is a diatomic element, the prefix di means how many? Two. And atomic means atoms. So this is a class of elements that when they're found in nature, they're found in pairs of two. All right, these are buddies. And they are two atoms bonded when found in nature. So if someone's talking about oxygen in the air, really they're talking about diatomic oxygen. These elements are not stable on their own, so therefore they have to buddy up. And here's my rough sketch of the periodic table. There's an easy way to kind of remember where they are. All right, so these elements, if you were to sketch them out, they look like this on the periodic table. They're here. Oops, I'm sorry. That was a really poor sketch. Anyone know what I did wrong? I included the noble gases. Noble gases are not part of these diatomic elements because noble gases are stable on their own. So where do these elements exist? If I were to shade the region in, they exist in from groups like 13 to 17. And we're going to tack on little hydrogen over here. So an easy way to kind of remember these is this part right here looks like what number? Looks like the number 7. So we call them the super sevens plus this little tiny sidekick. The sidekick is hydrogen. So when they're diatomic in nature, this is where you're going to have O2. So if I were to kind of fill in the pattern where they are, we have N2, O2, F2. I'm just kind of doing a rough sketch of where they are on the periodic table. So when these guys are found in nature, they're found with the same element buddied up, P2, S2, Cl2, Br2, I2, and their little buddy over here is hydrogen. So they kind of make, just nod your head and say, okay, it looks like a 7. It kind of looks like the number 7 and hydrogen. So these guys are found buddied up in nature. All right, so those are the two things that you need to know before we do a skeleton equation. So what a skeleton equation is going to present like, it's going to present like a word formula or like a word problem. So it might say lithium, gosh, I use lithium all the time, potassium combines with chlorine trioxide to form potassium chlorate. Okay, so this is why we did the lesson on Monday and Tuesday where you have to figure out, do I have like a single element? Is this a diatomic? Is this ionic? Is this covalent? Because it's not going to say this ionic compound, blah, 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 or using prefixes. So you have to be able to name this on your own. And that's part of the practice that I have set up for you guys today. I have, in a PowerPoint, I have the lines drawn for you. And you have to either drag and drop the correct formula in or write the correct formula in based on what you see. So the first thing I have is potassium. All right, so what's the symbol for potassium? Okay. And it combines with, so that's my plus sign. I already have it written here for you. It combines with chlorine trioxide. Well, I see a prefix here, so I know I'm not going to use the ionics. So chlorine and then oxide tri, okay, chlorine trioxide. And it's going to form potassium chlorate. All right, so that 8 ending right there lets you know that this is ionic. So potassium, then we have chlorate. It's 1 minus. So my charges cancel out, so therefore I just write it. So essentially, we're not saying problem 1, potassium. Problem 2, chlorine trioxide. Problem 3, potassium chlorate. We're putting it all together, and we're asking you to now write the skeleton formula. So then you've written a chemical equation. All right, let's try another one. Remember, you can always pause the video, go back, look at it. All right, so let's say I have magnesium fluoride reacts with dibromide to produce magnesium bromide and difluoride. Okay, so if you need to, pause this and then come back when hit play when you're done. So I would, if this were the homework, I would provide you with 4 lines. Is this still recording? All right, so we have a line yields this and that. Okay, so you just take it step by step. Magnesium fluoride. Okay, I don't see any prefixes, so I know I should probably see if I'm crisscrossing. Magnesium has 2, fluoride needs 1. So I crisscross. MgF2. That's the original ionics that you guys learned how to do like a month ago. Dibromide is just bromine, and the prefix di is 2. It produces, there's that arrow, magnesium bromide. Well, I'm going to crisscross. All right, so how did I get that? Well, Mg has 2, bromine needs 1. I'm going to crisscross. And difluoride is F2. So that's what you're going to do today. The first couple of slides are just notes. And then I think there are 3 or 4 slides for you to do practice with. And there's a slide then at the end for extra credit. So you know how to do this. Don't be like, oh my gosh, there's so many words. It's so difficult. Just break it down. Use the strategies that I did. Underline. Show your work. Some of you tend to ask, can you do a slide activity on loose leaf and submit it? Yes. If you work better on paper, I totally get that. Go ahead and do that. So this assignment that I'm going to assign you today will be due tomorrow by midnight.